probably we should be live now. Hello, hello. Welcome to June's office hours. We got a small rebranding, so now it's our office hours. Yeah, today we got some guests. So how about you start by introducing yourself?
I guess I'll start.
Oh, go ahead.
Hi, my name is Gabriel. I'm one of the engineers at Cloudbase. I'll be doing a demo today of GitHub self-hosted runner manager.
I'm Mike Tugeron. I work at Adobe. I'm here just because we're doing a bunch of stuff with ARM64 with Flatcar.
Cool. Tony, Joseph, do you want to also introduce yourself?
Sure. Hi, my name's Tony Goslin. I also work with Adobe. I work with Mike and also with Joseph Sandoval. I'm here to see what's going on.
I'm Joseph Sandoval. I thought you all knew me already, but I'm with Adobe as well. And I'm coming in, I did have a follow-up item from the Flatcar session that was given at Rejects in regards to Flatcar and the direction it's going with community upstream. I think that was talked about. So looking for an update.
Okay, sounds good. No, we do know each other, just like making sure that everyone in the room know each other. So like cross-checking. All right. So let me share my screen and we could go over the agenda for this week. It will work in a second. Of course, it takes me too much time. Okay, found the right window. Can you see my screen? Great. So I think we all introduced ourselves. Yeah, and mentioned that we got a rebranding for office hours. And we have a Slack channel, if you don't know it. So here's a link. Yeah, maybe Tilo, you want to take the next one?
Oh yeah. So for the time being, we will relax our release cadence a little to give the maintainers team a little breath. Currently, our release are still involve a lot of manual steps. If you're curious, just look at release tracking issues in our issue tracker. For each release, we have such a tracking issue. And there are, I think, up to 40 steps that the team works through for each release. We have almost finished work on a much more automated release pipeline. And we're going to tie up those loose ends in the future and basically bring it all on. Actually, first results you'll see in the demo today that Gabriel will do on GARM, because GARM already uses the new pipeline, elements from the new pipeline. Until we have everything automated and integrated, we'll just give ourselves a little more time and we'll relax from releases every 2 weeks to roughly releases every 4 weeks. Of course, if any major issues are detected or if there are any major security issues, we will definitely issue an out-of-band release. This is to give the team time to stop pushing the bike, to get on the bike and start driving the bike.
Cool. So I think now we are back to Gabriel.
Hi. Let me just share my screen.
Oh, okay. I think I didn't allow it yet. So should be okay now.
All righty, share. And I think you should be able to see it now.
Yes, we can.
Not sure how we can. There we go. There we go. All right. So a few months back, I submitted a PR to the scripts repository in Flatcar. It was for configuring compression algorithms for the outputted files of Flatcar. Now, the whole process was very nice, but the minus in that process was that I couldn't see what was happening in the CI. at all. So I had to rely on the nice folks from Flatcar to shuttle information from the private Jenkins CI into the GitHub pull request whenever something broke and I needed to fix it. So soon after that, I started looking into a way to create a workflow for the scripts, at least for the scripts repository, to run those CI steps and for people committing to that particular repo to see the results right inside the actual pull request. Now, the first attempt failed very badly, mostly because the default GitHub runners have only 2 CPU cores, and Flatcar being a distribution, a Linux distribution, has many packages you need to compile, and that means it takes a lot of time. Just compiling the Flatcar packages without anything else takes roughly 5 hours. And there's a time limit of about 6 hours for every job in GitHub to run. So GitHub just canceled my job and that was it. Now, to get around this, there are 2 options. One is to create a GitHub workflow that creates resources on an external cloud somewhere. So create a VM, a larger VM in any cloud you wish, and use SSH from that job to run the steps inside that particular VM. The other one is to use GitHub self-hosted runners. Now, GitHub gives you the actual binary, the actual worker used to run GitHub jobs. You can set it up yourself on any server you wish. It'll join GitHub and you can use it. You can reference it using a self-hosted tag or any other tags that you've used. Now, this runner has 2 modes of operation. One is the ephemeral version, where after each job, GitHub just removes it from the list of runners, and the permanent version, where you can reuse it over and over again. Now, the permanent version, you'll need to clean up yourselves after each job to ensure that you have a clean environment in which you run the tests. Otherwise, your tests will be tainted and you can't really trust them. So the self-hosted version is usually what you would like to use. This basically ensures that you have a clean environment each and every time to run those tests. Now, managing those self-hosted runners means that after each job, you need to be able to tear them down automatically and spin up another one automatically to replace it, so that when the next job runs, you get a fresh worker that's ready to run your tests. So I started fiddling around the APIs and came up with GARM. Basically, GARM means GitHub Actions Runners Manager. That's all it is. So I'm going to show you how it works. I don't have slides. I don't like slides. I'm just going to go through the thing so you can see it in action. It has native support for Lxd, which can run containers and virtual machines. Now, I must mention, GitHub recommends 2 open source projects, one of which is an operator on Kubernetes, but that gives you a containers runtime. So for Flatcar, that's pretty difficult to use, considering that your SDK runs on Docker. And the other one is a CDK for AWS, essentially. So you're stuck with AWS. GARM was written in a very modular fashion. It has native support for Lxd, which allows you to run on any bare metal machine, a VM with Linux. And it has also an external provider, which allows you to write your own binary that interfaces with whatever cloud you want. We wrote a couple of them. One is for, let me make this bigger. One is for OpenStack, and one is for Azure. And they're essentially just bash scripts that GARM calls into just to create the necessary resources inside a particular cloud. So let me get to it. To use GARM with your repository or organization, you just have to create a personal access tokens with access to your repo or organization. I already created one and configured it inside the GARM config file. It's a static config. The plan was to use something like Vault to store secrets. So for the time being, anything that implies secrets is, except for the Webhook Secret, and I'm going to show you that in a second, is inside a config file. So credentials list. This is my personal access token, which I'm going to reference when I'm going to configure my repository or organization. Now, the providers are just an OpenStack external, a local LXD on this machine, and an LXD installation on an Ampere ARM server. So I'm going to show you both, the local one and the remote one. To create a repository, all you have to do is garm CLI repo add, and the help for this is pretty simple. We just need the credentials, which we reference. So in this case, it's Gabriel. The name of the repository, scripts, and the owner, which is my user. And of course, the Webhook Secret. So the Webhook Secret is used to validate the webhooks that coming from GitHub. So whenever a runner is added or deleted, or something happens in the workflow that we care about, a webhook call is sent from GitHub to Garm, telling it that a new job is queued and we need a new runner, or a job is done and we can remove the old runner. So now we added a repo. We need to create a pool for the repo. So we have essentially a few layers in Garm. So we have the repository or organization, we have the pool, and we have the runners. You can have multiple pools per repo or organization, and each pool has multiple runners of the same type. So you can mix and match whichever way you want. In this case, we have this particular repo added. Now we need to create a pool for it. So garm CLI pool add. And here we have a bunch of options. Let's start off with enabled false for now. The flavor is the size of the runners that will get instantiated. So in LXD, the flavor is the profile. The profile allows you to specify how many disks this particular instance will have, how many NICs, RAM, CPUs, and so on. I only have one flavor, one profile, which is the default one. We'll use that for now. The image is the usual LXD image that one would use. So Ubuntu, for example, 2004. Max runners and min idle runners. So this is the maximum amount of runners that the pool will handle, after which it won't create any more runners. And the min idle runners is essentially a set of warm booted runners that linger and wait for jobs to happen. So if you have, for example, an operating system that boots slowly or something that boots slowly, you might want to increase this option and have a bunch of them ready to run jobs. Otherwise, you can just leave this to 0 and Garm will spawn one up whenever it's needed. We're just going to leave those to their defaults for now. The repository, the one we just created. OS architecture. This will be AMD 64. OS type will be Linux. Provider name, this will be local LXD, the one that we showed here. It's LXD local, actually. Okay, and tags, this is important. This you'll use to target runners that get spun up by this particular pool. So let's go with Ubuntu. Local LXD, for example, and whatever else with my runner. These are arbitrary, so you can add whatever tags you want. You can use these tags in your workflow to target this particular pool of runners. So now we have a max runners of 5, min idle runners of 1 for this particular repo, and it's not yet enabled. So if you do a garm CLI runner list all, there's nothing. So let's enable it. So garm CLI pool update. Sorry about that. Update this particular pool. Enabled true. Now it's enabled, and we can do a garm CLI runner list. We should still see it. Here we go. Let me just full screen this. It's pending create. Now it's creating. And if we look at LXC list, we see that it's already being spun up. LXC console, we can see this booting. Cloud Init is starting up the setup process soon. So these are the default images from LXD. Nothing non-standard. You can build your own if you want with whatever pre-installed stuff you need. But for this demo, it's just a plain vanilla image that comes with LXD. It does the updates. And now it fetches the GitHub self-hosted runner binaries. On archives, let me just show you garm CLI run list and so on. And we can do a show on this. And we can see the updates happening here as well. Configuring runner. Installing runner service, successfully installed, and it's now idle. So if we switch to our repo, let's try settings, actions, runners, we see it here. So it installed, it spun up, it has our tags. It also has a bunch of default tags like x64 is added automatically, self-hosted, and Linux is also added automatically. And these are some tags we add that keep track of runners created by a particular GARM installation. Now, if we do a GARM CLI pool list, and sorry about that, -r, pool show, we see that we have this instance here attributed to this particular pool. We can also update the pool to create more idle runners. In idle runners, let's say 3. And now we see that 2 more will be created shortly. They're in pending create. Now they're creating. And we see them being spun up here as well in LXD list. Now, if we want to add another pool to this for ARM, for example, we do a GARM CLI provider list. We have this particular provider, which is an Ampere ARM server. Not exactly sure of the model, but it has a bunch of CPUs that we can leverage. Also with an LXC installation, we can do a pool add, and I'm going to just enable it by default, true. Flavor default repo, that's okay. So let's do an ARM64 this time, Linux provider name, Ampere ARM, tags. This is also an Ubuntu, and it's running on an Ampere, so to speak, and we should be good to go. It's already enabled, so if you do a GARM CLI or ls/a, this is in a different pool, which is this one. It's pending create. Now it's creating, and we should see it here as well. It's already running. We're not going to wait for it to boot. Eventually, it will come up and show up here. Now, if we want to use this, we just have to go to actions. I have a dummy action here. We can just run. We can target my runner tag, for example. It just prints some info, sleeps for 1 second, and exits. Run the workflow. It's been picked up by this particular runner. It finished. So it just does a uname -a. We see that it's on 64-bit, just dumps some file system information, and that's it essentially. But what's interesting is that when that happened, the old one was deleted, which is, hang on, let me check. Which is this one. So this one was deleted. And the new one was spun up to replace it. So we still have 4, the 3 from the first pool and the 1 from the ARM pool, this one. This one is new. And this one was deleted. Now, let's see if show. Here. So here we go. It's downloading the tools, extracting the runner. This one is the ARM64 one, running on NPR. Installing dependencies. These are the dependencies for the runner. Authentication. Successfully added. And if we go to our runners, we should see we have also an ARM64 one. We can just run it. And this time with ARM64. This is the runner. Oops. And here we go. This one was killed, removed. It's no longer there. And we see that a new one is being spun up on the same ARM server. There we go. And that's about it. So essentially, GARM is a simple tool. It's single purpose. You don't need anything complex to learn. Everything you just saw is everything that it does. There's nothing more complicated than that. All you have to do is define your repositories, your organizations, perhaps, create a pool with the definitions you would like to have that pool, inside that pool, the operating system, the size of the machine that you would like to use, and you're done. GARM takes care of everything automatically. So you don't have to, once you've set up your pools, you can target them. You can create a pool in Azure. You can create a pool in AWS. You can create a pool in OpenStack, LXD on bare metal, or any other cloud provider. You can write a bash script or a Python script or any kind of executable you would like. GARM can use it and can interface with it and can essentially create resources in basically any target cloud. In parallel, you don't have to choose between one or the other. You can give each pool different tags and target them in your workflow. GARM will take care of the rest. Any questions?
Yeah, so that looks all very good. Thanks a lot for that. Just yeah, like a side question. So what do you think? Because it kind of takes longer to boot up a bare metal instance for a workflow. And yeah, the compilation of Flatcar takes a lot of resources, but it still looks like it could be done at least to a certain amount in parallel on a server that's strong enough. So do you think it makes sense to use Lxd to?
Yeah. So I've tested with 8-core, with 16-core, and it didn't add much to this. So at one point, your bottleneck is your download speed. And it took 1 hour and 19 minutes and 59 seconds to build the packages. It's using the same stuff I found in the Groovy files attached to the GitHub PR that I was involved in. It builds the images, sorry about that, builds the images and builds the VM images. So this all happens in within 1 hour and 20 minutes, essentially. Using 16 cores didn't add much. I didn't add anything at all, actually. So you can essentially have a bunch of bare metal Equinix machines. So this was run on an Equinix machine, on a VM on an Equinix machine. You can have a bunch of them inside an LXD cluster. You can use LXD clustering, and you can spin up VMs on top of that with as many CPUs you'd like, with as much disk space as you're allowed, and with as much memory you'd like. And it should be good. Setting up LXD is simple, just LXD init, follow the steps, enable networking, and GARM can connect to it using the same credentials that the CLI does. So you'll need the client certificate that gets generated automatically. So for example, in this case, it's in snap LXD common config, not this one actually. So snap LXD, parent maybe? Oh, not here. My apologies. Snap LXD common config. So you have the client key, client CRT. GARM can just use this, and the server certs, which you get once you connect using the CLI. So I have a bunch of remotes, 2 Ampere ARM servers, the local one, of course, and these are for images. But if you'd like, you can use any cloud. So LXD is just one cloud-like system that you can use. Bare metal directly, I'm not sure it's worth it unless you want to use some specialized hardware that's available only on the actual hardware, and which you can't just PCI pass through to the VM. But in most cases, you can just pass it to the VM. So for example, OpenStack allows you to do this with virtual GPUs, for example, with NICs, FPGAs. So you can essentially use whatever your cloud allows you to use. GARM just says, I need an instance of this type with the following characteristics, installs the runner on it, and you're good to go.
Okay, so and that was Ubuntu container or Ubuntu VM with LX?
VM. So GARM just spins up virtual machines for various reasons. One is that you might want to use an SDK like Flatcar has that needs Docker to run. The other one is security. So allowing GitHub workflows to run means that you may potentially be running untrusted code, and container is sometimes not that hard to break out of, while a VM adds an extra layer, well, not bulletproof, adds an extra layer of security. So you limit any malicious code's ability to run on the host itself. But you still need to take great care not to trigger the workflow unless the code that you're trying to test is trusted. You can do this in GitHub by limiting the automatic running of workflows to contributors, past contributors, or current members of the repository, and just do it manually or based on a tag or something of the sort. But you have to take great care when running untrusted code inside your CI always, even if it's GitHub workflows or Jenkins or whatever, because you want to limit the amount of malicious code that may run. So security is important. Containers are nice, but you need to trust the code that you're running inside them. And if you look here, it's a virtual machine.
I really love this. And only just by listening to your presentation, thanks a lot, by the way. This is amazing. And only just by following your presentation, I realized that in the new CI automation pipeline, there's like a small gap that we didn't consider, which your tool exactly fills, and that is how to connect individual workers or runners to GitHub actions or tags or whatever we use to build and to test PRs. That is awesome. Thank you for the presentation.
My pleasure. One thing you should know, if you're using an organization, you can actually reuse runners from different repositories. You can trigger actions from other repositories from a particular repository. This works in organizations, or if you have, for example, 2 repos under the same user and you have access rights to both. So you can potentially build the packages, upload artifacts, use those artifacts in a different job running in a different repository. So this is also possible from what I understand.
Nice.
Yeah, what GitHub doesn't have, unfortunately, and this is something that most projects usually build on their own or use something that's already built, is unit test aggregation. So once the tests are done, you need something to aggregate those results and present them in a fashion that are easily digestible by everyone, and that allow you to do flaky test detection. So a history of test runs and their status, if they succeeded, if they failed. For example, the Kubernetes folks have test grid. Test grid. They have this. For example, and you see, for example, here we have a test that's flaking a lot. But this is something that the Kubernetes folks set up themselves. I'm not sure if this is open source or not. The idea is that you need something like this to aggregate the results over a period of time and do flaky test detection and stuff like this.
We have the lower level part covered, where we can run like any number of tests on automatically on any number of vendor backends, and we rerun tests that are flaky, and we also collect the test results, and we sum it up to a single like yes or no, depending on if any of the tests failed. We don't have visualization yet, but the tests and the test reports that we deliver are in tab format, so there should be tooling that can visualize those results. But it's pretty great to have.
Yeah, I mean, this is a minus. I mean, this is something that's missing by default in GitHub, and it's mostly due to the fact that each project wants something different from visualizing their test results and keeping track of flaky tests and some such. So I'm not sure if this is something that's missing in GitHub, or if it's something that is expected for projects to implement if they want. You may not even need it. So
I think it can be retrofitted pretty easily from the low-level bits that we already have. So that's
yeah.
It is another gap. Sorry.
I just thought it's something that I should mention in regards to GitHub, because some people need this, and you don't have it by default. You need to have your own thing. So, but
True.
Not necessarily. If you don't really need it, that's fine.
Cool. Any more questions? Thanks again for the presentation, Gabriel. This is
my
definitely
pleasure.
very, very useful, and we'll pick it up in Flatcar and put it to use.
Awesome.
So I think next we have Dongsu. Right?
Yes. I'm going to share my screen. Yeah. This is our Flatcar release planning board, and the last release was at the end of the May, actually beginning of the June. Actually, that was Alpha 203255 and so on, and that was about 2 weeks. And the next release will take place 1 week after that. 3 weeks after that, so 1 week after this time. So let me click on it. Several PRs were already merged, including Containerd, Docker. Also, some security updates are in progress, like Vim, Containerd, glibc. glibc is actually just a package update, but it's kind of a huge update, probably not going to make into the next release. Also, there are several planned ones, so these are not started. So if you are interested in updating these packages, so feel free to jump in. And let's see from the draft. And Also, there are a list of merged PRs here in the column of release June 20th. So please have a look. And probably we need to discuss today's like what we should do with the recent update of the ARM64, which was yesterday merged by Tilo. This one is usually going to be included in the stable version probably 3 months later. And so I've heard that that was not going to be good for Adobe folks. So I would like to listen to what be the solution to that. Yeah, Mike?
Yeah, I was just actually I had my hand raised for this to just ask what the kind of timeline was to get some of this ARM support in place, and what the release process would be like for it. We would like to go to production with ARM64 sooner than 3 months from now, if possible. But one of the things that's blocking us is the SSSD support, because that's how we SSH to our hosts. And unfortunately, you know, without that being supported on ARM, we won't be able to go to production. And so we're just trying to get an understanding of, you know, at what point would that be available, and what's the release cycle like for adding in that kind of functionality? Does it have to go through the alpha beta stable process, or, you know, just I'm not familiar enough with the release process to understand how it works.
Yeah, thanks. So there is actually no hard time lineup for that, but usually we would say that new stable version, major version would be updated once in 2 or 3 months. So in this case, if we create a new alpha next week, June 20th, then after 3 months, that would mean September 20th or earlier. So who knows when, might be sooner or later. So is this the deadline for end of August, a hard deadline for you folks?
I mean, hard deadline is always a flexible term. So we're trying to figure out some of our deadlines. We had hoped to start rolling it out towards the more beginning mid of August to our stage clusters, with potentially the production, you know, across, I don't know, 20, 30-ish clusters around that time frame, with production clusters coming a month or so, maybe 2 months on the outside after that. So from a production perspective, that would work. Just it's a few hundred hosts, you know, in the staging environment, much sooner than that, which is where it kind of gets a little concerning for us, that we would end up, you know, with the SSH access being a little bit limited. Well, I mean, quite a bit limited, which it is something we can work around. It's not ideal, but just yeah, I'm kind of rambling.
Just to throw an additional point here, with our particular situation, we tend to slow our releases to our production environments towards the end of the year, being the holiday season and whatnot. I would imagine probably other folks are in the same situation as well. So the sooner that we can deploy ARM into our staging environments, the sooner we can get into production, the sooner we aren't up against the wall in terms of that kind of slowdown of our production releases.
So maybe to add, in the past, we cherry-picked stuff like that to the beta release and also to the stable release. if we thought it's worth to have something backported. And yeah, the general feeling is that we should only do it when it's necessary, because sometimes you think it's working well for you when you developed it and tested it, and then it affects somebody else's use case in unexpected ways. So that's why we kind of don't do this by default, but we could do this. And I think if we say we try to cherry pick this for the beta release and then have some more people look into how this works for the beta release, and we can also do another cherry pick for the stable release, and maybe while we are releasing it, point somebody of you maybe to this image and validate again whether it's really working before we kind of mark it as go and push it directly to everyone.
Yeah, I'm definitely not advocating for cherry picking directly to stable at this point. Just to be clear, I definitely don't have a problem with. If we were to be cherry picking towards like a beta for the upcoming June release, you know, we can definitely do a bunch of testing on it very soon. You know, after within a couple of days after that release, and give you any sort of feedback at that point for it. Yeah.
So just raised my hand to kind of stand in for my PR. I did most of that work. The potential impact is pretty limited. First, because it only affects ARM64 images, and second, because it merely adds a number of tools that then are additionally shipped on ARM64. It doesn't change any existing tools. It doesn't update any libraries to newer versions. It updates one library ebuild to a new ebuild release, but the library version remains the same. That contains a cross-compilation fix. And from that point of view, I would agree with cherry picking it to the June beta. So Mike, you and your team would have all of July, basically, end of June, all of July, to really test whether the feature fulfills what you need and whether there are any side effects. And then based on that feedback, we could consider for the end of July release to then cherry pick that into the stable that we're gonna release end of July. Or we could also promote the beta we're going to release in June to stable by the end of July. I just checked, and the last major stable release that we did was beginning of April. So that would kind of fit into the 3 months stable update cycle as well. But that's to be decided at the point in the future. Would that work for you folks?
I mean, from Adobe's perspective, that timeline would be perfect. You know, if that fits within your process and your timelines as well, that would be great from our perspective.
There's still a little bit of headroom until we start working on the release, and those dates are basically the weeks that we plan to release. So the new release is not going to happen at the 20th, but in the week of the 20th. So we have a few days left to put some extra eyeballs basically on the change and make sure there are no unwanted side effects.
I was expecting it on the 20th at 12:01 a.m. So. No, that's totally fine.
Oddly enough, the CI automation that we're working on is partially there to make exactly that happen, but it's still a few months out. So maybe later this year.
Awesome.
Cool. I think we have a path forward. Of course, no guarantees. This is the process, right? So I'm gonna create an issue in the issue tracker for cherry picking this change into the upcoming beta, and we can align on that issue if that works for you.
Yeah, sounds good.
Great. Thank you so much. I appreciate the flexibility and the help.
This is what we're here for. This is basically this forum, right? It's the office hours, and it's exactly for this kind of discussion. So thank you for your contribution.
Cool. So I think that concludes the meeting, right? Or anyone else wants to add anything before we finish? Thanks for joining. Nice to have a big forum today. Yeah, have a lovely day.
You too.
You.
Take care.
Bye-bye.
Bye.
All right, thanks, everyone.
Thanks, Danielle. Bye.